Hello, Britain. In the previous video, we stopped with the idea of transforming or the transformation of absolute value functions, and we mentioned that it's very similar to the transformations happening with the quadratic equations and the curves. So the idea that we just stopped at was having a stretch or a shrink of a function. Now, here are the two parameters or constants that we're going to deal with. We have a outside the absolute value, and we have 1 over b, where b is multiplied by the 1 over b multiplied by x. Now, one of them is responsible on the vertical stretch or shrink, and the other one is responsible for the horizontal stretch or shrink. What does that mean? Now, I just wrote this elastic. That's right here, okay? Let's say that this elastic is our curve, or in this case is our v-shaped, which is the v-shaped absolute value function. So for example, this is the parent function. It's a v-shape. Each of them makes 45 degrees. If this v-shape was an elastic and we stretched it vertically, so it's going to be up. So stretching in this case actually means compressing it. So sometimes you might get confused with this. Always remember this idea. If you're stretching it vertically, that means you're getting closer into the y-axis, which means it actually shrinks. But it's called vertical stretch. And vertical shrink is the vice versa. So you're just stretching it like this, and you get it shrinking vertically. For the horizontal part, it's the other way around. Let's have an example to see how this works. So for example, stretch the graph f of x. Let's just have this here. Stretch the graph. Here we have a graph that is f of x equals x plus 1. The question says, have this function stretch vertically by a factor of 2. Stretching vertically means we're talking about, or we want a factor that is multiplied by the whole function, because if it was vertically stretched or shrink, so if we're talking about a vertical movement of the function, here I'm going to write it here. So if it was vertically both stretch or shrink, that means the value, which is a, is multiplied by the whole function f of x. Okay, a is multiplied by all the function, the absolute value and any number that is next to it. So it is multiplied by the number that makes it shifts up, down, or right and left too. Okay, for the horizontal, okay, horizontally both stretch, or shrinks. Okay, this means that the 1 over b is multiplied only by the x itself. So basically f of x is going to be f of 1 over bx. So the factor is multiplied by the x, not by f of x like in the other case. So in this question, we said we have f of x equals the absolute value of x plus 1. And the question asked us to make this graph stretch stretch vertically by a factor of 2. So when it says vertically, that means we want to multiply the factors given by the whole function. So our function is f of x equals the absolute value of x plus 1 is multiplied by 2. So it's going to be, let's call it g of x. The new function that we're finding is g of x is equal to the factor a multiplied by f of x. A in this case is 2. So it's 2 multiplied by f of x, which is the absolute value of x plus 1. That's g of x. So g of x is 2 of the absolute value of x plus 2, because the 2 here is multiplied by the absolute value of x and multiplied by the 1 here. Okay, so if we graph this, we're going to get a very similar shape into this is the original one, this is the parent function, so we're going to call this f of x, but the only difference that our f of x in the in this question has a plus 1, which means it's shifted upwards in the y-axis. So this is f of x, actually it's on the 1 right here, and it has a v shape, a perfect v shape. Now then, this is f of x. I'm going to call this, instead of calling it f of x, I'm going to call it parent function, because it's the original one, it's not the given in the question. And then we have g of x, which was changed. Now g of x, what happened to it, it was stretched vertically by a factor of 2, which means it's going to be closer to the y-axis. I'm going to use another color to make it clear. So here, it's going to be closer to the y-axis, which means it faced a vertical stretch. Okay, so I'm going to assign 3 different questions for you. What I want you to do is I want you to find the vertex of the new function, the domain, and the range, because at the end of the day we're still dealing with functions, and this way you can even revise the previous lessons.